In this video, I'm going to go over the calculations with significant figures. Hopefully you've already viewed the video on when to count significant figures because we're going to apply those rules to calculations as well. Looking at then calculations using significant figures or following significant figures through calculations, there are two basic rules. One rule applies to addition and subtraction, and one rule for multiply and divide. Our addition and subtraction rule is what we're going to look at first. What it states is that it's limited, but also must retain to the number place of the original number in calculation that does not go as far across on the number line. What we're actually looking at there are the number places. If you think back to elementary school, it's like the hundreds, tens, ones, 1/10, 1/100th, 1/1000. You're worried about number place. So let's see what that looks like with an example. You'll notice for my example, both of them are 5,000 minus 2,587.6. If you put this in a calculator, it's going to produce the same exact answer, 2,412.4. So I'm going to go ahead and write the same answer for both of these. Now, where it's going to have a difference, though, is once we now apply this rule, the addition subtraction rule, to this calculation. So I'm going to go back and look 5,000 minus 2,587.6. I'm going to look at each of these initial numbers individually, and I'm going to find all significant figures in those numbers, and then I'm going to locate which one's the largest number place for each. So let me show what that looks like. So 5,000, applying my rules from counting sig figs, I know that my 5 here is significant. Looking at 2,587.6, I know that all of those are because they're 1 through 9. Now when I read this number left to right, the one that goes all the way to the right, so the very last one to the right, is where my last significant digit is located, or significant figure. So in this case, it goes over to the 6. Now, each of these have a number place. You don't have to label the number place, but this would be in the thousandths place, and this would be in the 1/10th place. What we're looking for is which one doesn't go as far across over, or the other way to think of it is which is the larger number place. In this example, 5,000 is a larger number place because it's to the thousandths place. This is the one that's going to limit my answer. So that's the one that limits. Okay. So when I go to my answer, I have to find that same spot where this one stops and limits. I have to find that same spot in my answer. So in that case, it would be the 2 here that's in the thousandths place. That's where I'm going to actually stop my answer. However, though, I still need the 2 to be in the thousandths place. So I'm going to go ahead and when I look at this 2, I also need to look when I'm going to stop my number here. That's where I'm going to round it. So I have to look to the right and follow the rules of rounding. So 5 and up would round up. In this case, it's a 4, so it's going to stay at 2. So I keep my 2. And then in order to keep that in the thousandths place, I have to fill in until I normally would get to that decimal. So I fill in all the other number places that keep that 2 in the thousandths place. I do not put a decimal at the end because that would make those zeros significant, which we do not want them to be significant. We only want this 2 that's in the thousandths place. So that would be my final answer, and that would be correct for this calculation. Let's look at the second example. Again, same 2 numbers, produce the same answer in the calculator. This time, though, when I look, I see that all of these are significant. Same with this one, all are significant. So both of these numbers, when I read left to right, go to this 1/10th place. My answer can now go to the 1/10th place. Therefore, my final answer for the second example would be 2,412.4. And that would be the correct answer here. So again, just to review addition, subtraction, what you're looking at is calculate your answer first. Then when you go to round that answer to the correct number of significant figures, you're going to be looking at where the last significant digit's located, what number place from the original numbers that you've calculated. with those original numbers, whichever one is the larger number place is where you must then round your answer to that larger number place. So that's addition, subtraction. Let's move to multiply, divide. This one's actually a little easier to do because it's simply taking those rules we learned from counting significant figures and you're applying them directly to this, and you're basically counting the sig figs in your original numbers to then your answer, and they must match. You're limited by that least number. So by definition, it said limited, but also must retain to the least number of significant figures from the calculated numbers. So let's see what that looks like. What I suggest always doing is putting in your calculation to the calculator, then getting that full answer. Once you have the full answer, then worry about rounding it. So if we take 8.6 divided by 1.5, we're going to get 5.73, and the 3 is going to continue to repeat. Okay, so it's actually going to be 3, 3, 3, 3, and go on. I'm just going to write a couple of them down there at this point. Looking at my rules, what it says to do then is we're going to count the sig figs. So 8.60, I know this 8, the 6, and this 0 are all three significant. So this number has 3 sig figs. I'm going to put underneath. The 1.5 has 2 sig figs. So the one that's going to limit my answer is the one that has the least number of significant figures. So 3 here, 2 there. It's going to be the 1.5 limits. That means my answer must only have 2 significant figures. So if I read this answer left to right, I count 1, 2. I'm going to stop this number here where the 7 is, but I have to still apply my rules of rounding. I look to the right. It's less than 5, so it stays a 7. 5.73333 turns out to be 5.7 is the final answer. It only has 2 significant figures because this original number only had 2 sig figs. Let's see another example. 24,500 divided by 150. This again gets me 163.3, and the 3 continues to repeat. I'm only going to write 2 of those down. I then count significant figures. 24500, this is going to be 1, 2, 3. 150 only has 1, 2. Therefore, the limiting number is going to be this one that only has 2 sig figs. Again, that had 3. This only had 2, so that's the one that limits. So I read my number left to right. I keep 1, 2. I look to the right of the 6. It stays a 6 because, again, that's a 3. So this then, I keep my 1 and my 6. Now, just like we had to do above, the 6 in the answer here is in the tens place. I need to keep that 6 in the tens place. In order to do that, I fill in with a 0 that does not have a decimal. Now my answer has, just like my given here with 2 sig figs, it now has 1, 2. So that is my final answer, 2 sig figs. Okay, hopefully you found this video useful. Thank you for watching.